There is an alien portal in the abandoned downtown Oakville Taco Bell freezer. It's time-locked and entombed in its own sort of liminal space purgatory. Thankfully, you have befriended the little teal freaks trapped inside and decoded their language. No one believes you, and you got some bad news from a doctor. You have money and some technical skills, and for some reason think the best way to share this info with maybe a more understanding future generation is HTML and CSS through a website. The main reality of things on the internet is they die. From platforms going out of business, to organizations that stop caring, to solo maintainers simply passing away. What would be needed to keep a website running without intervention, let's say, after we're gone? Although a simple system design challenge, running a static website, the constraint of running for decades is hard, if not impossible. We of course don't know how long the internet as we know it will exist. But let's assume we got some money in a bank account and a legal trust that can pay a bill here and there, and there's a post-ironic Internet Explorer resurgence in the 2080s mixed with nostalgia keeps the web as we know it alive until, the big plug is pulled by some 250-year-old Al Gore. Something, if I brought you into this world, I can take you out of it. I don't know, that was Nixon? Reagan? From DNS to hosting to the code to the version of CSS we use to the file format of the media, all needs to be handled potentially differently for a forever website. The thing is, unlike other forms of engineering, very rarely do we think about the implications of our decisions beyond a few years. Like the Y2K bug, where short-term thinking in early computer systems, using a 2-digit year instead of, a 4-digit year to save memory, created massive problems decades later. Engineers in the 60s and 70s couldn't imagine their code would still be running in 2000. For our forever website, we need to avoid similar short-term optimizations that could come back to haunt us for the future alien curious. Let's look at the scenarios if we're in an interview system design challenge. We need to have a website that can be found with a name. We have to have static content with our Rosetta Stone information, and a picture of the freezer with its location. And we also need some style on the website because we can't let people think we're a kook. And it has to be accessible from a browser as long as we have these, and it needs to be accessible forever. A crutch that makes this at least semi-possible is we have some sort of legal trust with a good credit card or Bitcoin or whatever on file, and to answer governance requests like who is, and to pay our hosting bills. We want to be able to focus on the technical challenges today. But we have to think through some of the challenges here. Why is this hard? I'm sure many of you assume this is hard based on the fact that the modern internet is built on a grave of dead links and broken sites and content that once was. But why is that true? Well, technology requires maintenance, upkeep, support, and money and care. For example, where are we going to host this forever website? Not going to be easy finding places that have a shot at being around that long. And what if the host kicks us off, or goes out of business, or changes in a way that we can't update our site to support? Can we have multiple hosts in a way that can be sustainable? What about vulnerabilities? Presumably this will be an issue if we're unable to update our site. And how do we keep the code working? Browser APIs change or are deprecated. Supported versions of HTML and CSS and the media that goes into it also change. What will browsers support in the future? And dependencies will change and stop working and disappear. Also, will the internet be based on the same core technologies? Can we really depend on things that would otherwise be obvious? Like HTTP, do we need to support Gopher? What about DNS? And does any of this have any sort of redundancy that we can count on? I think for success here, we should focus on a few fundamental ideas. First off, did you know you can still access the first website in its original form? Well, you can. There's probably something to that. The fact that these technologies used to make the first site still run today is incredible. This is explained in part by the Lindy effect, a concept suggesting that future life expectancy of non-perishable things like technologies is proportional to their current age. In other words, the longer something has already survived, the longer it's likely to continue surviving. This principle reinforces a core intuition I have that more established web technologies will likely outlast newer ones. HTML is from 1991, has more staying power than a framework released last month. Which leads into probably also we want to focus on open standards over what might be trendy. Just because it's used today doesn't mean it's going to be supported tomorrow. For example, in the 1990s and early 2000s, during a time referred to as the browser wars, Netscape Navigator and Internet Explorer were battling for supremacy. In this time, they each created proprietary features that only worked in their individual browsers. Sites would then proudly display best viewed in Netscape Navigator or optimized for Internet Explorer. This fragmentation, though, was disastrous for web longevity. Many of those features don't work today. Thankfully, today, though, there is a much stronger focus on web standards through organizations like W3C that has improved compatibility enormously across the web. So I think we do want to be building to those open standards. Also, we probably want simple. Maybe I'm just a bit burnt out because my day job is working with systems that look like this, but more moving parts is probably going to mean more things that can break. If we introduce complexity, there needs to be clear fallbacks, and we can use techniques like progressive enhancement. But more on that later. Starting with the easier stuff, the contents of the site. Still otherwise harder than it would be. Remembering our fundamentals here. Something like React, a JavaScript framework created by Facebook, has significant market share of trendy relevant sites. This might seem tempting for its power and market relevance, but it's dependent on a massive JavaScript ecosystem that evolves rapidly, and browsers may eventually drop support for the current JavaScript versions embedded. For example, jQuery, once the backbone of the web, is now considered legacy code. Using frameworks means betting on their continued existence, which history shows us is a losing proposition. Also, React has a mountain of dependencies. A typical React application might have hundreds of node modules, and React applications typically rely on numerous third-party libraries. This dependency graph makes long-term maintenance challenging, as a single dependency breaking or becoming outdated can affect the entire application we're building here. That being said, I'm not brushing off newer technologies completely. It's worth considering something like WebAssembly, which aims to create a universal runtime across browsers and devices. WebAssembly could potentially offer better long-term stability than JavaScript frameworks because it's designed as a compilation target for multiple languages, and has strong backing from all major browser vendors. However, it still is relatively new, just standardized in 2019. It doesn't yet have the track record we would want for true longevity. But I have a hunch, and just call it a hunch, that this would have been a much larger part of the conversation if I made this video 10 years from now. This brings me back to the phase I mentioned earlier though, progressive enhancement. It is a web design strategy that emphasizes core web content first, then adds progressive layers of presentations and features on top as the browser and user agents support them. It starts with a baseline of essential content and functionality that works on all browsers, then enhances the experience for users with more modern browsers. This approach will create a natural resilience when parts of the website fail, hopefully gracefully working on future systems, then breaking entirely. So HTML and CSS is what we're going to want to use as our backbone here. And if we use JavaScript, only minimal amounts that have clear fallbacks to that basic content. Even then, we should be mindful of what components we use. HTML, hypertext markup language, the part that puts the content on the screen, has a graveyard of once popular elements. The blink element, introduced in Netscape Navigator, funny enough, the second shout out this video Netscape has gotten, made text flash on and off. It was pretty annoying until it was deprecated. There's also the marquee element, which created scrolling text effects and was a staple of 90s websites, but is now also deprecated for accessibility reasons. And there's others, including frame, frame set, applet, and font. Browsers may still render these elements for backwards compatibility, but they could disappear at any point, and future specs completely could, overwrite these. On the other hand, some HTML elements are original from HTML 1.0 and have survived every revision since the early 90s. The humble anchor element for creating hyperlinks is the backbone of the web's interconnectedness. Similar for the paragraph in H1 through H6 for headings and basic tables. All have maintained consistent core functionality for more than 30 years. These elements represent the fundamental building blocks of web content and are extremely unlikely to lose support. Recent HTML5 additions like details, summary, picture, and semantic elements like article and aside offer powerful functionality that is used across the web, but haven't been tested for decades of browser evolution. Moving on to CSS. CSS is the style for the page that we're going to be building today. CSS has a similar story. Some properties have weathered decades of browser evolution, while others have come and gone. The original CSS1 properties from like 1996 with things like color and font family, margin, and padding have remained remarkably stable. They work exactly as they did 25 years ago and will likely be supported indefinitely. By contrast, vendor prefix properties like, I don't know, WebKit border radius or, Mozilla box shadow were temporary solutions before standardization. Many early CSS layout techniques have been unofficially deprecated as well. We used to have things like table-based layouts and flow-space grid systems. While technically still supported, they've been replaced by more robust alternatives like Flexbox and Grid, which many of you have probably worked with. Lastly, we want a picture, and there's a ton of picture formats we can use here that have met the criteria. They've been around for a long time and are open standard and are well supported. For example, things like PNG and TIFF and GIF, all things that have been around for a while. But if this is a picture, there's one clear best format, we all know what it is, that meets our requirement, and that is JPEG. Newer formats have better compression features, but JPEG has been around since 1992. It has universal support, and although there's newer standards like WebP and AVIF, I realize you never say those out loud. These standards might be technically superior for the web, but their future is less certain, right? Everything supports JPEGs. This goes back to the Lindy effect that we talked about earlier. The longer something has already existed, the longer it's likely to continue existing. JPEG is a web standard and unlikely to be unseated anytime soon. Now we get juicier though. Let's spend some time with the address bar. Starting with the domain name, which again would normally be a non-issue if it wasn't for the forever thing. Top-level domains, the little bit at the end here, are generally controlled by ICANN, Internet Corporation for Assigned Names and Numbers. It's a non-profit organization formed in 1998 that coordinates domain names and IP addresses globally. They're essentially like the phone book managers of the internet, overseeing the domain name system, crediting domain registrars, and determining which top-level domain, TLD, exists. While technically independent, ICANN operates under a contract with the U.S. Department of Commerce, which has historically given the US government significant influence over global internet governance. But ultimately, top-level domains are overseen by governments and international agreements, so their stability varies wildly. For example, the startuplove.io domain has already an uncertain future. There has been concern it can go away completely, even though it's widely used. That could be all sites that use the .io domain would have to switch to a different top-level domain, effectively killing their SEO, content links, and promotional material. All could disappear because of geopolitical nuance. On the funny flip side, consider that the .su domain for the Soviet Union still works despite the USSR dissolving in 1991. Something that might be phased out by 2030, but you get the point. While newer vanity TLDs have also uncertain futures, no TLD is truly guaranteed to last centuries, but some have more institutional inertia than others. There was an initial set of generic top-level domains defined in RFC 920 in October of 1984, which was a set of general-purpose domains. This is where we get the ubiquitous .com, .edu, .gov, .mil, .org, and kind of .net, although that's from a different RFC from the same time. It might be obvious to pick one of these. Well, we don't meet the criteria for three of these, not being a school, or the US government agency, or the US military, so that leaves .com, .net, and .org. .com, the most popular by far, with over 100 million registered domains, seems like the obvious choice. It's worth noting that .com has the oldest continuous registered domain still active today, symbolics.com. It was registered in 1985, originally belonging to a computer manufacturer. It's changed hands, but it has remained registered for nearly 40 years. But play with me in the space here for a bit. If what we're saying is on this site is that there's aliens in a sleepy North American town, let's say the US government doesn't love the fact that we're sharing that info with the greater world. Although no longer run by the US Department of Defense, .com is still ultimately under the jurisdiction of the United States. What if we wanted to get out from under the boot of this anti-alien deep state? What are our other options? We could run with what many hacker non-US friendly sites do and register the pair of the .ru and .me domains. .ru for Russia and .me for Montenegro. There's context here that I'm brushing over, but a mixture of the lack of ability to register the .ru domain and with its overall reputation, let's say, is mixed at best. We probably don't want to be messing with the .ru domain. Montenegro has a better global perception with .me. Many, I would assume, don't know it's tied to the country of Montenegro, but it seems susceptible for a .io situation. Although global stability is higher than it used to be, Montenegro used to be Yugoslavia. Yugoslavia also used to have its own TLD, .yu, that guess what? Is no longer usable. What I'm basically saying here is there's still trade-offs. Maybe a middle ground is something like .nz. Although an ally of the United States, it's a politically stable country run with strong values of political and personal freedoms. I feel like the great people of New Zealand also would be down for the idea of aliens, and the domain is run by a seemingly non-evil nonprofit Internet NZ. For the purpose of the next few steps, let's assume maybe either both .com and .nz. We can have .com for ultimate stability and NZ as a backup. Unfortunately, this is more of a social marketing issue. Things like redirects would only work if we're in possession of the domain to do the redirect. So it's more of you can hit either. The problem's also where to register these domains. We need a registrar, which is our first problem. You can't have multiple registrars per domain. Whoever we pick, we will be depending on a single organization or company to maintain our domain name. Now, naturally, we would want to lean into financially stable, well-embedded companies. But even then, this might be an issue. Google, for example, killed their domain registrar in the last few years. Thankfully, when this does happen, many of the existing registrations are transferred, but this is still not ideal. Even once we pick one, or one for each domain, the idea of registration and renewal also has to be taken into account. According to ICANN's 2022 updated registration data policy, domains can now be registered for up to 10 years at once. This is good. Previously, it was capped at only 5 years. But then we get to the point of re-registration. We could automate some sort of tooling that could also eventually break, or someone that has owned a domain for nearly 2 decades, we can let them auto-renew and hope that the credit card info is up to date. If companies go out of business, they are transferred to places that hopefully keep taking our money. Registering a domain name is all about managing risks and making trade-offs. I'm pretty confident in this system of auto-renewal will last 20, 30, even 40 years, given the stability of the system in the past and the motivation of the internet to maintain the importance of these systems. But I need to admit, for our design, it's still putting a large reliance on a single individual company to keep taking our money. So that's DNS. I had to cut like 10 minutes out of the script just talking about the quirks of DNS, so let me know if you're interested in that being its own video. But now onto the other side of the address bar. HTTP. HTTP is Hypertext Transfer Protocol that powers the web, allowing browsers to request and receive web page. It's the application layer of the internet that sits above TCP and IP that we learned about in my last few videos. It's been around since 1991 and proved remarkably stable despite several version updates. HTTP 1.1, the first version truly rolled out to the web, has extraordinary staying power, still widely used today. Well, there's newer versions with HTTP 2 and HTTP 3. They offer improvements, but backwards compatibility has carefully been maintained. I would assume any replacement for HTTP would likely maintain backwards compatibility for decades due to the massive existing infrastructure, including billions of web servers and clients and proxies and CDNs and load balancers and security tools and frameworks, all designed around the HTTP protocol that's super embedded with the web. Also, there's not very many alternatives. In the early 1990s, a protocol called Gopher rivaled HTTP as a document retrieval system, offering a menu-based interface that many found more intuitive than the early web. It was widely used by universities and governments, but mostly due to a licensing snafu, it didn't become mainstream, and by 1996, HTTP had clearly won what was called the Protocol Wars. Interestingly, Gopher has experienced a small revival in recent years. A community of enthusiasts seeking a simpler, more content-focused web experience has begun setting up Gopher servers and browsing with specialized clients and browser extensions. But still, this is no real threat for HTTP. Same for protocols like Gemini or the alternate web systems. None have gained significant traction, even close to talk of standardization. HTTP's ubiquity makes it our safest bet. But some of you might be screaming at your screen or already said in the comments, HTTP is already threatened, and some could argue even semi-deprecated for HTTPS, or Hypertext Transfer Protocol Secure. Yes, this is still HTTP, otherwise referred to HTTP over TLS, but it has a few gotchas. HTTPS is what encrypts your web traffic from the server. It's the little green lock that you used to see on the top left of the address bar. I don't know when these went away. I thought this was actually still a thing until I was talking about it looking at it for this video. HTTPS eliminates whole swaths of attack vectors from the scary hacker in the coffee shop parking lot to your ISP selling your exact porn preferences to third parties. HTTPS is objectively a good thing for the internet. Because of this security importance, it is getting aggressively pushed. Many default web server configurations automatically redirect HTTP traffic to HTTPS. Web browsers and search engines also prioritize it and ultimately are pushing for a world in which it's the default. This is a problem for us, though. Encryption requires authentication, and authentication in this case requires an SSL TLS certificate. Although registration windows for domains are getting larger and larger, like we said earlier, up to 10 years, the opposite is true for registration windows for TLS, and auto-renewal is a bit more complicated, because the certificate, once renewed, needs to be updated on the web host. A process that is normally trivial to automate, but this automation will have dependencies and API calls, and the automation itself would need to be hosted, which makes this more difficult for us. Some hosting providers will do this for free for us as a service they provide on top of their other services, but it's not built into the spec, and it's leaning on proprietary tooling of these hosts. Thankfully, though, this isn't fully doom and gloom. Although tooling like browsers and servers prefer HTTPS, it's not 100% required, especially for static content, and it's still unclear it will ever be required. But we can hedge here. We can allow some automatic certificate automation from hosting providers that we use. For example, I have an AWS Lambda that has been up for nearly 8 years without intervention, accessible by HTTPS. In my case, AWS, Route 53, and the networking services in between just has handled this for nearly a decade. I haven't touched it. Even with this automation, we can disable any automatic redirects to HTTPS, allowing essentially the progressive enhancement we talked about before. HTTPS is available while the certificate is renewed, and HTTP is a fallback for when that doesn't work. But in the spirit of this whole video, we have to acknowledge that this is just a hunch or a wish. There is a world in which the browser of the future don't support HTTP, or our page will just be littered with warnings. But I believe this hedging here will set us up for the best success. So we got a website and a domain name. Now on to the more fun stuff, hosting. In normal system design, we would talk about HA, or setting up a service up for high availability. This is usually simplistically a conversation about horizontal scaling, which is usually distributing the workload over multiple servers or instances of an application behind something like a load balancer. If one host has an issue, it can be pulled out of the active pool of hosts, and the others can then serve future requests. Now, this is optimizing for uptime of a much smaller window than we're talking about for our Forever website. We care less if it's down randomly for 5 minutes, or even an hour, if there's an issue, as long as it ultimately recovers. This is an important caveat because we probably don't want to distribute only across multiple servers, but across multiple hosts and hosting providers, and hosting types in potentially geographic regions. Now, I know earlier I said we want to avoid complexity, and what I'm talking about now just sounds crazy complex, but think about the caveat. We probably don't need instant recovery and the mess of load balancers that would enable that. What if we just went more dumb and routed with DNS? When you register a domain with a registrar, remember this is who you give your money for the domain name, you usually set up name servers, which we can set up multiple, and we can distribute these across different points around the world. These are the servers that the registrar points to and has the records for your domain, such as an A record, which is the record that says this domain is at this address. That's an A record. Now, you can specify multiple A records in each one of these name servers. If one host goes down, it would just use the next one. But there's traditionally a problem with this. When multiple A records exist, most DNS resolvers return all the addressors, but in random order. Clients typically try only the first address and then move on to the next one only if the first completely fails to connect. This creates two issues. First, if a server is partially failing, like let's say it's responding slowly but not down, clients might never try the alternative, sending one user across the world to a bad address. Additionally, these records have no concept of health checking, so a dead server will remain in the rotation forever, frequently being checked if it exists. Also, if when a server goes down, the client that already have the address of the host cache will try to reuse the now down host and won't try the others until the cache expires, which, although we can set up this amount of time, it may not be honored for various reasons. What I'm saying overall is there's situations in which this might cause small bits of downtime when a host is removed out of the service, and the experience might be less than ideal without this complexity. But for our long-term website, these DNS limitations are actually acceptable. Because again, we don't care if it's down for a user for a few minutes when a host goes down. We care that overall the domain eventually resolves to a working host. And this is the key part that makes this round robin by DNS not that bad. Modern browsers also implement a feature called Happy Eyeballs, RFC 8305. It's an algorithm that attempts to connect to multiple addresses in parallel or with very short timeouts. This was originally designed for IPv4 and IPv6 dual stack connections. This approach helps with multiple A records too because it allows browsers to quickly check other addresses to help a first-time user better connect to a working host. Speaking of working hosts, I guess we can talk about that. We're going to want a few different options. First, we want to diversify across providers instead of an all-in-one single platform, right? We've talked about this to death already. Even one as stable and as ubiquitous as AWS and their static website hosting built into their object storage S3, consider that GeoCities once hosted millions of websites, but was completely shut down by Yahoo in 2009. Even Amazon has discontinued services, and no company is guaranteed to exist in 50 years. Of the original Fortune 500 companies from 1955, only about 60 remain today. Our hosting strategy would involve deploying identical static sites across multiple major providers in different jurisdictions, perhaps AWS S3 in the US, Cloudflare Pages in multiple global regions, and a European provider like OVH, and an Asia-Pacific provider like Alibaba Cloud. Each provider gets its own A record in our DNS, but this multi-jurisdictional approach helps protect against regional internet disruptions, provider bankruptcies, or even government censorship. By spreading across different business models, hyperscalers, CDNs, and traditional hosts, we also hedge against industrial-specific downturns. This geographic and business diversity maximizes our chance of maintaining at least one accessible copy. That paired with the round-robin DNS load balancing that we're doing will hopefully allow us to have the site accessible for a long time. So now we have a place or places to put our site. One of the funny elements of this design overall is it's incredibly easy to implement. So easy that I did it in an hour and a half. Here is our HTML and CSS, and we have some basic design and simplistic elements. We have embedded media without any CDN or third-party services. It's all right there in the site. Let's see how long it lasts. Okay, this was a fun thought experiment and just one way to think about preservation on the internet. But the problem is it's demonstrating a bigger problem with the web. Vint Cerf, one of the fathers of the internet, once warned about a potential digital dark age where data becomes unreadable as formats and software becomes obsolete. Now, beyond just preserving the data, he suggests the idea we should also be preserving the tools capable of reading the data, such as emulators and virtual machines. For example, to preserve a Flash animation, one might save the Flash player and software to emulate for it. This is exactly what the Internet Archive is doing. They use emulators in the browser for old software, and they have a collection where you can play classic DOS and Mac games directly in a web page. This is on top of the data and content archival work of the Internet Archive and their Wayback Machine, which has been capturing web snapshots since 1996. This is important and outside of nerd circles, thankless work. But something we should think about with our site is making sure it's regularly crawled by these tools, effectively creating a backup copy in their digital library. Now, myself and the Internet Archive are not the only ones to think about this forever thing. Somewhat different approach is permanent.org. Founded as a nonprofit with an endowment model, they aim to create truly permanent digital archives. Users make a one-time payment to store their content, and the interest for that collective endowment fund is designed to maintain the archives in perpetuity. While their focus is more on personal archives than websites, it's another interesting approach to keeping things alive. And lastly, I'm sure I would hear about it in the comments if I didn't mention it, there's also blockchain-based solutions. By encoding your site's content into the blockchain, it would theoretically remain accessible as long as the blockchain has active participants, potentially outlasting any single company or organization. Arweave offers permanent storage by requiring a one-time fee that funds storage in perpetuity through an endowment model like permanent.org, but it uses the blockchain architecture where miners are paid to maintain copies of the data. IPFS, Interplanetary File System, takes a different approach, creating content addressable storage where files are retrieved by their cryptographic hash rather than location. Combined with Filecoin for incentivization, IPFS could maintain copies of your site across a global network of storage providers. Both systems have theoretical advantages for century-scale preservation, but they're relatively new technologies without the established track record of traditional web hosting. Also, it's important to note that they don't have anywhere near the cultural relevance that we get with something like the web. So in summary, who knows? We can make educated guesses while looking at the past, but we don't even know if what we think about data, websites, or even information will be the same in the future. But I think it's still worth it to try. Holy moly, that was a big one. If you made it this far, come on, you gotta subscribe. The last few videos, people have given me a ton of comments about the things that I didn't talk about. So here, you got what you wanted. Here's a really long video. I still feel like there's things I didn't mention. So if you're interested in that other stuff, I'm thinking about putting like a cutting room floor type behind the scenes video that's way less processed than these videos are. I just got to figure out like how to distribute those. So if you're interested in that, let me know in the comments. Subscribe. It's helpful. Leave a like. I don't know what this call to action I'm supposed to do here.